All right, folks, we are now moving on to, the fun part of Unit 3, which is to build the Bouncy Ball app, which is the app build for this unit. Just so you're aware, I am working from the teacher's edition from the book, but you're welcome to use either the teacher or student edition. I am in section 3.3. The teacher's edition offers a preface to the app build, kind of talking about teacher-y kind of things, like what topics are covered and suggestions for teaching it. But the instruction portion of it is identical to the student version. You can use either one to help guide your build. But if for any reason you're lost in the process of this and you're wondering where I'm at, you can download either version of the book. This is the Xcode 13 version of the teacher and student book. So you can grab those for free from Apple and add it to your iBooks app. And I mean, really, you could guide yourself through this exercise, but I think that always is helpful to have a teacher to show you kind of some of the quirks and stuff. And then the other thing is if you ever want to revisit it or have something you can look at while we're doing the work, that's helpful too. So if you're multi-screening, like I am, most of the time, these instructions for me are going to be on the other screen, and I'm just going to be reading from them or using it as a guide for what steps come next. You're always free, of course, to take this app and embellish it, so like if you want to do like a fancier build of it and add more components to it or change the physics or whatever it is you want to do, you're welcome to do that. But I'm going to build exactly what's here in the book. I like this because it's kind of game like. So for a lot of us, that's why we get into programming in the first place, to learn how to create games. And when you see like, hey, this isn't all that hard to do, it gives you a lot of ideas, right? And it also teaches you that there's lots of libraries, tools, and APIs and stuff that we can pull in dynamically to speed development of such things, which is why you see so much stuff being generated out in the world. It also gives you a real appreciation when you look at a really well-designed game, both graphically and conceptually. The work that goes into that is really actually, pretty heavy, but there can be a big reward if you design something that people actually download and use. All right, so let's start out here by just kind of reading through this first intro area. And it says, we're going to build a game where players try to hit targets with a bouncing ball. That's kind of the thing. You'll learn what callbacks are and how they work. You'll also use a sophisticated API. And by the way, API stands for Application Programming Interface. It's pre-written code where we just utilize the tools within it rather than create those tools from scratch. This is how a lot of development work is done, by the way. So you don't want to reinvent the wheel when it's already been invented, right? So how to use incremental development to build a complex app one piece at a time. And that's really, I think, an important takeaway here, maybe one that you wouldn't think about, but whenever you're building something complex, it's very difficult to kind of do it all in one fell swoop. Usually you do little pieces at a time, test each piece, and then move forward, right? Making sure all along the way that things are working. And then we're also going to learn this concept of refactoring, which is basically updating your code or changing it or doing it in one fell swoop. And this is a programming keyword. Refactoring is a really important keyword in programming. And so you'll basically add that to your vocabulary of terms that you'll know. So when you talk to like somebody who seems like they know what they're doing, you can throw the refactor word at them and see if they're clever programmers or not. I'll be real frank. I've been coding for a long time, and the use of the word refactor really, I think, has grown in popularity maybe in the last 10 years. And I've never seen it used so much as I do now, right? In the past, we didn't think of it that way, but it's still an important concept. All right. So some of the key words here: incremental development, callbacks. That's an important thing too, which is talks about how information travels through an app, basically, and refactoring. And it says, so far you've built simple apps with minimal code, and now you're going to tackle the challenge of building a game that uses physics and touch interaction. and it'll look something like this. And this is kind of the neat aspect of this book, is they have little video examples of what you're about to build. And this is an iOS version. So here you go. You drop your ball, it bounces, and woohoo! Some pretty exciting stuff. And then you move your little bumpers around, right? And you drop the ball and it bounces somewhere else. And then you kind of like your goal, if you're not seeing it, is to kind of control the bounce of the ball, whatever, maybe not quite so exciting, but the goal, I think, is to try to hit all the different platforms there. There you go. There's an example. And then you see that we're running this with a mouse on the screen because it's in a simulator. But there's a goal basically to hit all the little diamonds and hit all the little platforms for the game. That's kind of how it operates. All right. So it says here, in this lesson, you'll be following common software development strategy called incremental development. You'll build the Bouncy Ball app in stages, each one ending in a working app, and you'll run and test the code at each step, gradually building its capabilities. And, that is a really important takeaway. I already talked about it, right? You can't expect to like build, Battlefield in one fell swoop. That's probably not going to happen, right? So you might think that you could look at the game in the video and build the app all at once, but think again. It will be much easier to build the game bit by bit, increasing its complexity in manageable steps. And along the way, you can evaluate your code and make adjustments where the need arises. Then you can test after each step to make sure the game is behaving the way it should. And this is really, this technique is key. And a lot of developers use this type of approach because, you wouldn't want to have to build a whole bunch of stuff and then wait like days to see if that thing that you built worked, and then discover days later, oh, that part doesn't work at all. So now I got to go back and change everything because, so that's why people build in incremental steps, and all along the way, keeping it, keep the application runnable basically so that you can test it, right? And that's really kind of a key takeaway too. All right, so first step that we have to do is open the project called Bouncy Ball Xcode Proj, which is right here in your code file. You will notice that there's a iOS and a Mac OS. We're going to build the big one here. And I'm just reading the instructions to make sure I'm doing it the right way. And it says from the Bouncy Ball folder, click and run the Xcode toolbar, blah, 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 blah. Okay. So, I'm paraphrasing a little bit. So I'm going to go ahead and open that up. That'll open up inside of Xcode. I am going to close my playgrounds in the background here. And I think I have at least one open. And I'm just doing that kind of for a number of reasons, partially to free up memory on the machine so everything operates well. You guys do know that, sometimes Xcode can choke a little bit. So if you have other playgrounds that are open in the background, it's not a bad idea to close them, right? So just less memory usage, especially if you're like on an 8 gig machine. I think you'll find it pretty darn helpful to do that. All right. So now the app is up and open. It doesn't look very exciting, but there are a bunch of things already present here in terms of assets and a structure. The focus that we're going to have is for iOS. We're going to try to build exactly what we saw on the screen. And I mean, you can do this for the Mac OS too. So like, that question was already asked, but the reason we're doing the iOS version is basically because the simulator fits on the screen really nicely. And I think it's just a little bit easier to control the parameters of the application. Okay, so we're on the part 1 now, which says putting shapes on the screen. And it says you'll build the entire game from simple elements, flat shapes that can interact with user touches, and a physics simulation. The code that implements the game engine is written in the shape and scene files that we see kind of over here on the side. And it says, in turn, the game engine is written on top of the standard iOS Sprite Kit API, which is much more complex and powerful, by the way. As you progress through the lesson, you learn the game engine's API. and this is not an unusual approach for coding, right? So like when we try to create virtual objects in simulated space that behave like real objects in real space, like so when you think of like you take an actual ball and you throw it, like say toss it down the sidewalk and it bounces a few times. You know what controls all of that is basically the natural physical world that we live in. So the gravity of planet Earth, the force that I throw the ball, the material the ball is made of, maybe how much air is inside the ball, you know, maybe the wind's a factor or the angle of the surface is a factor in how it bounces. But some things are constant. So for example, in the real world, gravity, or at least on Earth, is a constant factor. So there's a certain amount of pull that happens with an object that has mass towards the surface of the planet, right? So, and then if the object is able to bounce somehow and goes up into the air, there's a force of gravity that pulls it back in a certain way. And this is all calculated. So like people in physics and mathematics have calculated these things, and those formulas are then added to these APIs, right? So like we don't have to like figure out what the formulas are for, you know, the arc of an object traveling through space at a certain rate of speed with a certain amount of gravity after throwing it with a certain force and with certain amounts of bounce capability. None of that is in our brain, right? But if we were writing this completely from scratch, right, and just have you like understand the beauty of an API, we would have to calculate out all of those formulas, build them into functions and methods and whatever that we can then call to make the ball bounce the correct way, right? And so the beauty is when we have these pre-written APIs, and physics libraries in gaming are pretty standard, you know, these days. There's certain ones that game developers always pull in, and hey, we need a gravity physics thing. Okay, well here it is. You know, this is for Earth, right? And I don't know if you guys have ever played a game where like gravity is altered, like you're in outer space or you're on a moon and the gravity is less, and you know the physics are different, you know. Or if you play games like Mario or something where the physics are completely sort of like unrealistic, you know, or exaggerated, right? So those are parts of those APIs. In this case, we're using an API that's pretty realistic in terms of how that operates. All right. So it says to start, it says use the project navigator to open game code. And so you come up here to the top and you just click on that, and that will open up right here inside the code window. Right, so that's the this is and it says here in the instructions, this is the only file we're going to need to modify as we create the game. So all the other stuff is like pre-created objects that we're not going to mess with, basically. All right. It says you'll notice that the game code already has one function in it called setup, right at the bottom, right? And this is called once the app launches. Without it, your app won't compile, right? So this is an important one that drives the code and makes it run, right? So without that there, and you can see that there's already instructions here. It says the setup function is called once the app launches. All right, well, it's the same thing I'm reading from the book, I guess. And it says you can create many other functions as you want and declare variables and constants at the top level of the file. Outside any function, you can't write any other kind of code. For example, if statements and for loops at the top level, they have to be written inside of a function, right? So they can't be at the top level, they have to be inside of a function. This is just kind of how this environment kind of operates, right? And they give you this information here. If you want, you can delete these comments if you wish. They don't have to stay there. I might delete them just to kind of conserve on space as we go. Right. Now, first thing that we're going to do, and this is always weird whenever we're working with GUI apps, but we call this, by the way, a clean build, right? Is there's nothing in the application yet. We're just going to build it and see what it looks like. Now, a couple things that before you hit that run button, right? And I want to have you remember here, up here at the top, you can propagate the device or choose the device you want to propagate to. And I'm pushing to an iPhone 14 Pro. That's what mine says, right? And I suggest that you choose something kind of on the modern side, and preferably an iPhone since we're working with basically an iOS app. So go ahead and hit the run button, let it launch, build the foundational code, and get that simulator running. Right. You can see in the background here, the simulator is up on the screen. It is now booting my phone, right? And then it will push the app into it. And there it is, completely blank. Yay. Right. There's like nothing in it. Right. All right. But still, you know, and I always found this fascinating when I first learned how to do GUI programming. I'm like, why would you run the app and build it when it's empty? You know, but it builds all the code structures underneath. It precompiles some things that then speeds up subsequent builds is really what happens. Like when every time we hit that run button, if any code is changed, it builds that code. If the code hasn't changed, it uses the version that's already built, but it uses the executable that's already present. And therefore, subsequent runs happen faster. And we also are sure that, hey, you know what, there's nothing wrong with this pre-built code that was given to us. This runs. You know, that's the other aspect of it. I am going to hit the X there. I am going to hit the stop button back inside here. And then I want to get the panels back to where I want them. And that's kind of a little bit of an annoying feature is when we close an app, sometimes it pops us into like the app delegate or the view controller. I think usually the app delegate in this case. All right. So first thing we're going to do is we're going to actually put a shape on the screen, and it says at the very top of the file, just below import foundation, we want to add a little bit of code. So we're going to define a circle. And so we're going to set that up as a constant. I'm just going to call it circle. This basically, I think, will create a ball. And circle is basically what we call an oval shape. So we'll type oval shape, parentheses. And then you can see the parameters we have to add here. So we want to put in a width and a height. These are doubles, but they are basically a pixel count right on the screen. So it's really declaring a size. So they want us to do, you know, a circle is basically an oval that is equivalent in height and width. So I'm going to put 150 in for both of these. I have a circle defined as an object. Now, we gave it a height and a width, right? And you know, it's not going to be visible yet, right? Because we haven't given it any reason to be visible. We haven't put it on the screen yet is really what's going on. So what we're going to do now is down in the function setup here is we're going to give it a position. So I'm going to say circle dot position, right? And so, you know, where's this coming from? This is coming from the oval shape method library. So you'll recognize oval shape as a type, right? And position is one of its either calculated or pre-generated properties that's put in. Now, what we're going to do is we're going to feed values into this. So we're going to say point. So we're going to pick a point on the screen to locate the circle. And we are going to use the XY approach. Now, we talked a little bit just before we started about what X and Y means on a screen. So I'm just going to reiterate that really quick. And that is that when we're working on a screen, the top left corner, way up in the top left corner, is considered 0, 0 for X and Y. And actually for Z too, but you know, we're only worried about X and Y right now, right? So on a two-dimensional plane. X here will be 0 up in the corner, but as I move to the right, X will get larger. As I move down, Y will get larger. It's kind of upside down, but 0, 0 is up here. And if I were like on a high def screen, like a 1920 by 1080, that X and Y would be down here. I'm not sure exactly what my resolution here is. I think it's a little bit higher on the screen than it is on my main laptop screen here. So we want to put in an X and Y position, and what this is going to designate, if I'm not mistaken, is the center point of the circle relative to 0, 0, XY in the corner. What they want us to set it for is 250 for X, and then 400 for Y, meaning 250 pixels over from the left, 400 pixels down from the top, right? So just to kind of indicate that. Now, interestingly, just because I gave it a size, just because I gave it a location, doesn't mean it's visible yet. And this is strange, but that's how this stuff works. So we have to do this thing where we are going to add to the scene, or the visible part of the screen, we are going to add the object that we just created and positioned, which is called circle. Select it like that. So we give it its parameters first. We, tell it what it is, where it goes, and then this command actually puts it on the screen. All right. Now here's kind of the fun part. Well, let's run it again. Let's see what we did. All right, and this is the incremental approach, right? One little thing we added to the screen. Let's see if it shows. Right. So here comes the run. We're building. It says build succeeded. It's loading up in the simulator. There it comes. And woohoo! That is really exciting, right? All right. Well, it tells us a little bit about how these tools work, though. So when I call in an oval shape and I make it the same height and width, right? And then give it a position, it'll appear on the screen. And it's interesting how it appears, right? It's a big black circle on the screen. Now they're asking us to do something else, which is try dragging the circle around the screen. So, oh, wow, I can do that. Apparently so. So I can click on it and move it around. Interesting, right? I mean, not only can I put it on the screen, but then I can move it. Okay. And okay, so I'm operating this simulated iPhone with a mouse, but if I was propagating this to an actual device, I could use my finger to move it around and interact with it. All right. Simplistic, but at the same time, I think kind of interesting and powerful. I'm going to come back over to Xcode here, hit the stop button. Did yours go okay? Yours built okay?
Yep.
Fantastic.
I had to download an update, but I'm doing all the work with you. So
Okay, excellent. All right. So now I'm moving on to the next instruction set here. So the next thing that we have to do is we have to, add the physics aspect to this. So in other words, the part that makes it simulate like it's operating in the real world with gravity and all that, and forces and whatever. And we have to give that circle, or the ball, if you will, those capabilities. On a screen, that's not necessarily the case. And this is kind of an interesting thought. So just because I put stuff on the screen doesn't mean it's going to for example, if I put a circle on the screen and there also happens to be a square on the screen, if I drag it, it won't be like they bounce into each other or know that each other are even there, right? So we actually have to do this thing where we invoke a property from the API called has physics. So we're going to do this, and we're going to put this inside the setup function, by the way, right? So let's go ahead and add that. And what I'm going to do is I'm going to put this, personally, I'm going to put this at the top of the function here, right? So I'm going to say circle dot has physics, and you can see how it just pulls that up. And then this is a Boolean setting, and we can set it to true. Now, just a little fair warning, and this is listed in the instructor's book. If you throw this in the wrong spot, so, and this is one of the points that we're making really early on. If I cut that and decided to put it up here, it should throw an error. And notice what it says. It says expressions are not allowed at the top level. Right? And that's kind of what they were putting here. You can create as many functions as you want, declare variables and constants, but you can't write any other kind of code. This falls into that category. By the way, this is another type of code, right? It's not one of those. So I'm just controlling my way out of that, but I thought it's kind of important to show you that. All right. It says run the app now to observe gravity in action. So let's look, here we go. I'm gonna hit the run. Oh, all right. Well, it ran and my ball fell right off the screen. I guess that gravity thing is working just fine, right? You know, if I think it's pretty hilarious actually when you start to think of it like that. But I'm going to go ahead and hit the stop button there. All right, so let's go ahead and add some more objects now, and we're going to need some of those barriers that the ball can bump into. And the shape of these barriers, by the way, is basically rectangular, right? So we have to create some different shapes, and basically, you know, there's a whole library of different kind of shapes that you can pull in. But when you think about the way shapes operate, like, okay, so circles and ovals are kind of related, right? Squares and rectangles are kind of related, and then there's objects that have more than 4 sides, and we typically call those polygons, right? And we're going to kind of work a little bit with a bunch of these, and basically the code's all provided here, so we're just kind of following along with what the author is basically asking us to do. It says add the following declarations to the top of the file underneath your declaration of the circle. So that stuff's going to go here. I think I am going to get to the point here. This is probably the right time to just take these comments, and you know what? I'm just going to delete them. Adding my code up here at the top. So the first one is I'm going to declare let barrier width equal 300.0, right? So that tells you it's a floating point number, or double. Right? And then we're also going to set let barrier height equal 25. Right? What does this equate to? Pixels, basically. It's kind of, I think, interesting that they're not making us do this as integers, right? Which tells you that the floating point aspect is important because, and here's the why, if you translate to different screen sizes, the 1 pixel amount on one screen might end up being a fractional amount on a different screen when you scale it, basically. And it also allows us to do more accurate math when we're moving things around the screen. Now, what we're going to do is we're going to set up an array. I'm going to do this kind of very incrementally here. So here comes the increment. So we're going to say, we're going to take the barrier words. We're going to declare where the X's and the Y's are for this. So I want you to think about this. With the circle, we set up its shape or size first, did the same thing with the barrier, right? Basically width and height. But now we have to, unlike the circle where we found the center point of the XY, now we're going to find the corner points of that object because it's a rectangle, right? So it actually has 4 corner points relative to it. If I declare, and I want you to think about this, and maybe I should draw on the screen here just a little bit to kind of demonstrate this as a concept. But if I'm drawing, you know, a circle and I find its center, then the circle draws around the center, okay? If I'm declaring a thing that's basically, you know, rectangular, and this is really rough, right? And if you remember from like how the game was, it was kind of tilted too, right? I can locate one of the points, and each one of the points in the corners, by the way, has an XY coordinate to it, right? So once I know the first point, X and Y, So I'm trying to draw X and Y. That's really hard to do. Sorry. Not easy with the mouse, right? Then the next one over, I know that if the width is 300, I mean, this X is that X plus 300 basically, or it's 300 pixels over, whether or not it's flat and level or not, you know, it might be on a radius or whatever, right? But that's 300 pixels over. And then whatever this Y is up here, that's going to be 25 pixels down to both of these Ys. So if you see what I mean, and then whatever this X is down here, this one's going to be 300 over from that X, or really 300 over from either X, right? So, I mean, this is kind of how the physics of a rectangle works, right? And I'm sorry for the absolutely horrid drawing with the mouse. I tried, you know. I had one of my instructor friends tell me, oh man, if you hook up your iPad and then you do the annotations, it's pretty slick. So someday I'll actually go to the trouble of doing that, but not today. All right, so what we need to do here is get points in. Now, this is going to require 4 points. Okay, so inside let barrier points, we're instead of like like, and I think, you know, always to like other languages for comparison, like if I was doing this in Java's got like their APIs where I just put in XY, 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 XY in order, and it kind of traverses the structure and defines the shape. And yeah, I can do that, but here I'm actually going to feed in an array of points is how we're going to do this. So I'm going to start with a square bracket and close that square bracket right away. And then inside here, I'm going to define all the points. So let's do 1 point. Here's point. And honestly, here's kind of what the interesting part of this is. It doesn't really matter which one comes first, but I like to put, you know, the top left corner first. Now notice what I'm going to do here is I'm going to put in an X and a Y, and the author recommends we start with 0, 0. Where is that? Top left corner of the screen. All right. I'm going to put in a comma, right, to put in the next point. So then we will point. Once again, parentheses. We're using the XY approach. The second point's going to be 0. And then the Y, we're going to move down whatever the height is. So I could type in 25, right? Because I know what it is. Or I can just use the variable version. And actually we want height, not width. So this is that offset I was talking about. Right. Another point. And one thing I do want to kind of point out, we already discovered, like with the ball, for example, when we put it on the screen, we could move it around. This is going to establish a starting point for this thing, which is 0, 0, but we can move it to anywhere on the screen that we want. All right. So the third point, once again, using XY, we'll start this time with the barrier width 300 over, and then we want to go down the barrier height. And then add a comma at the end. And then the final point, and an XY. We're going to go all the way over, so barrier width, and then back up to the top. So that's going to be 0. Okay. Now that establishes all the points, but now we're going to actually declare the barrier itself as a collection of those points. So this is where it gets a little interesting here. So we're kind of going down the rabbit hole a little. So I'm going to say, let the barrier equal this polygon shape with points. Which points? The ones that we defined in that array. Okay. So this part of it is very much like Java, right? So in Java, I would just sit there and declare, the points and the offsets and whatever, and I do it all in one fell swoop. What happened here is we set up an array containing a collection of points, and rather than typing all of this into here, right? If you guys can feel where I'm going with this, we just pre-created it and dropped the whole thing into there. That's just easier. That's just kind of the approach. Now, the next thing that we need to do is we need to put some of this code inside somewhere we can see it. That means we have to go to the setup function. And what I'm going to do here is we already have the circle on the screen. So there it is. You can see it, right? Now we're going to do the same stuff basically with the barrier, right? So first, let's start with the barrier, and then we're going to do position. Now, this is kind of interesting because remember the position of the circle wasn't really declared until we came here. Same thing is happening with the barrier. Even though we have a shape for it that it originally starts at, top left corner, right? Now we're going to change those X and Y points. So really what we're changing is the starting XY position for it. So I'm going to say barrier dot position, and then here inside of parentheses, we are going to say, oh, I'm sorry, we're going to say equals, not parentheses, I'm sorry, equals, and then we'll bring up the point, and that will be XY, and the point they want us to use is 200 and 150. And the other thing that they're wanting us to add is physics. So we'll just say barrier dot has physics. I should set that to true. And this gives it the capability to be basically a solid object on the screen, right? That the ball can bounce off of. And then we also need to add it to the scene. So we're going to say scene, add, and you can guess the code on this. What are we adding? The barrier. And this little piece here is an important part of GUI programming. The visible part of the screen, right? We think of the whole screen as the stage, and then the one view that we put on the stage is a scene. In order for something to be seen in the scene, you have to add it to the scene. That makes sense in your brain. The other thing I'm going to do here is I am going to move this little piece of code. So my format's the same. So I do position, physics, and add to the scene. You can do the same if you want. It doesn't really matter. All right, so just trying to be really methodical about this and just hit it one step at a time here. You guys good?
Yeah.
Yeah.
Excellent. All right. All right. And I'm just looking at the next set of instructions here to make sure we're not missing anything. All right. So they give us this whole gobbledygook. So I'm going to read it to you just so you guys, I do due diligence on this. And it says, even though there's quite a bit more code to create the barrier, you're not doing anything complex. In your declarations at the top of the file, you define the width and the height of the barrier. Next, you created an array of point instances that describe the barrier's four corners. Finally, you created a new polygon shape whose initializer requires you to supply an array of points that defines its vertices, right, which we did. And then the code inside setup just copies what you did with the circles, which is gives it a position, gives it physics, and puts it on the screen. And it says you may have noticed that the parameter in add is of type shape. Both oval shape and rectangle shape are kinds of shapes, so we can add the add methods. Okay, and so I think that it doesn't really matter which of those that you use. It's kind of the point. Build and run the app. You'll notice that your barrier will fall along with the ball since you've given it physics properties. So all right, let's do that. Let's get this to run, and then watch both of them fall off the screen. Right, because Great, I created gravity. Now I can't get them back on the screen. They're probably virtually still falling somewhere, right? And that's actually kind of what happens, right? Because unless you develop like a baseline, well, there is kind of a baseline, which is the bottom of the screen, but in principle, we never told them to stop. We just told them to like kind of go down a black hole. They sort of did. All right, I'm going to stop the app from running again. All right. Now, the interesting thing that they're saying next, it says both of them have an additional property that we haven't triggered yet. One is this one called is immobile, right? So that's a property for these objects. And if that's set to true, the shape won't move even when forces act on it in the simulation. So add the following inside the setup function. And I'm going to put this basically, I think I'm going to put mine here because for me, it makes sense. I'm going to take the barrier and I'm going to say is immobile. And then we're going to set that to true. All right. So now that thing's going to appear on the screen. If you remember, it was sitting below the ball. Let's see what happens when we run it this time. So run it again. Oh, hey, check that out. The ball fell and landed on my barrier. Now here's the fun part. Can you move this stuff? Hey, check it out. I can not only move it, right? Yeah, I can kind of have, this is almost fun in itself, right? But it shows you that the physics are now working. I can lift the ball, drop it, and it lands on the barrier. And I can move the barrier and it moves the ball if the ball's sitting on there. And I can actually kind of bump it a little bit too. It's not quite the bounce I would like, but it shows you that the physics are working and that the barrier now is not mobile, right? Which is kind of what we are hoping for here. You guys good?
Mhm.
All right. Let's move on to the next step. I'm going to go back to Xcode, hit the stop button. And the next thing that we're going to do is we're going to set it up so that we have that little funnel at the top that the ball drops out of. And we'll also start to set it up so that we can handle tapping on the screen, by the way. So that it says the two interactions that we're going to use in the game are dragging the barriers and dropping the ball. All right. We don't have to do any work to enable barrier dragging because the game engine already handles that for us, right? I just demonstrated that, right? That you can just do that and it just works. Next, what we'll do is basically handle that second interaction, which is the tapping, and then enabling a tap that drops the ball from the funnel, right? So if we're going to drop a ball from a funnel, well, we kind of need to create the funnel, right? So we're going to come up here to the top then, and underneath all the barrier stuff, let's go ahead and declare some things. And how you arrange your code now, this kind of falls on you a little bit. Like if you think like me, I like to like chunk things up to make them easy to see and kind of organize them together. So all the barrier stuff's together, the circle stuff's together, and now the funnel stuff will be together. I don't want that like intermingled in the barrier code or the circle code. So I'm just going to put it here. And I'm going to say let funnel equal. And once again, we're going to do an array of XY points, just like we did before. This is going to be a little bit more simplistic because we're just going to hard code all these. And in fact, what I'm going to do for the sake of efficiency here is I'm just going to paste these in. And I'll let you guys copy them from there. And you notice what happened is I copied from the book and it brought in all the junk from the book, like quotations, which is not something I wanted. So now I'm having to fix my square brackets. Oh, and you see what it did is it just put it in a citation. Okay, not good. All right. Next time I'll just type it. Then I'm just cleaning up my layout here, but you guys can. So we have 4 points. X0, Y50, 80 and 50, 60 and 0, and 20 and 0. And if you were to plot that out on a grid, by the way, um, it would make kind of a little funnel shape, a little narrower at the bottom than it is wide at the top. The other thing we'll want to do here is we'll want to do the same thing we did with the barrier, which is now that we have all the points declared, then we'll feed that into the polygon shape tool. So we're going to say let funnel equal polygon shape. And we're going to feed in the points, and the points are the funnel points, which is an array of points. You guys are good so far?
So far.
Yep.
Yep. Now, if you're following the pattern that we've been doing, right? So we set up all the parameters, right, for the object, and then we have to get that object somewhere where the code can actually put it on the screen, right? And so here, and you might want to do stuff like this, by the way. So like the book recommends, add a funnel to the scene. You could label all of your code if you wish. So then we'll just say funnel. Type that funnel dot position, just like we did with all the previous ones. And we're going to declare points. Which point is it? And we have X, Y. And we're going to set up 200. And then for the next one, we're going to do something a little bit weird, right? Which is we're going to look at the scene dot height. So this is a built-in property that comes with your screen, right? So the scene fills the screen, which has a height. So we're going to take that height and subtract it 25 pixels from it. And so we're moving it 25 pixels down to the top to put the funnel in. And then, of course, we have to add that scene or add that to the scene. And what are we adding? The funnel. So. I'll give you guys a chance to catch up here. Hopefully you got it all typed in.
Yep. Good.
I'm going to start adding some comments in here, like add a barrier to the scene. And I don't know if you find this helpful, but often I do, I do stuff like this when I'm coding, just so I know what I'm doing.
I do this with everything when in Java. Trying to learn that has been much easier when I add comments to everything, describing what it does, especially when you're building one in a way with blocks and getters and setters.
So once you guys have this typed in, you can go ahead and run it. And let's see what the difference is and see how that funnel pops up on the screen. So I'm going to do a run here. I think it's running, but apparently not. There's the ball dropping, and there's my funnel at the top, right? Right now, I will tell you, I think I see a little bit of a problem. I think that ball won't fit through the funnel.
No.
Can I move the funnel around? I can. That's probably not good, by the way. And this, well, all this stuff moves, but it's kind of interesting. But we already did set. Did we set the funnel so it couldn't move?
No, we didn't.
Yeah, we did not. Interesting. Yeah. So that's kind of an interesting thing as to why, okay, well, that's the question I have is why is that not moving? Why is that not dropping?
Because we didn't add physics to it.
Ah, there you go. Right. Right. That's a good catch, right? So if I would have added physics, then it would have gravity, and then that would be pulled down to the bottom. We don't want the funnel to move, so we just don't add the physics. It's just a visual element, you know. All right, let's come back over and hit the stop button. And now we're going to learn a little bit about callbacks. And I'm going to like read through this from the book here. So it says when the user taps the funnel, you want the ball to drop. You can write a function to drop the ball, but you never call that function directly because it's determined by the user's tap. Remember the question bot, right?
Okay.
So we had the response to thing that was called every time the user tapped the ask button. The question bot had a link from the button to the corresponding code, right? And that was real primitive, but it did have that link. So linking the code to user interactions is essential to app programming. These links are commonly known as callbacks. A callback is a bit of code, often a function that runs when something happens that you don't control, right? So you can think of it in, they say here, the term callback as describing the way an app can call back to your code rather than you calling the functions yourself, right? So there's no call to the code unless the user does something on the screen that forces it to happen. That's really kind of the grand point, right? You're not invoking the function, the user's invoking the function, right? They're calling back to the code to invoke it. So in this project, you'll learn one way to set up callbacks. First, you'll need to write the code that will run when the user taps the funnel. So below the setup function, create a new function to reposition the ball, right? And so the first thing I'll say here, so below the setup function, is I'm going to put in the comment that they have in the book, which is drops the ball by moving it to the funnels. Type that correctly. So that's what the function is going to do. Right. So let's go ahead and name it. We'll call it func, and we'll call it drop ball. Friends. And curlies. Right. Scroll down so we can see all of that. First thing we'll want to do, let's think about this. Where's the ball going to start? Inside the funnel, right? Or maybe above it, who knows? But so I can say circle position equals funnel position. Now I have some thoughts about this. Like, is this the right place to put it? Okay, well, let's just assume this is correct for now. But it seems pretty logical, right? Where are we putting the circle? Up by the funnel, right? Whether or not that works out precisely correct, well, that's a whole separate thing. It says next we need to set up the callback, and it says a shape has multiple ways of responding to user interactions. Each of these callbacks is just a property that tells it which function to call. Add the following call or code to the end of your setup function. So this goes at the bottom of setup. And here we will say funnel dot on tapped. So when people tap on it, that will drop ball. Now this is kind of an interesting thing in and of itself. So I want you to like just take a look at this code for a second. The book's making a point of it too. It says normally when we see a call to a function, what do? We put parentheses after it, right? When we're calling a function, because it's a function, right? That's just what you're supposed to do. And then like so you know, normally we'd say like drop ball parens, right? And then in that situation, you usually think of them as actions that perform work when you call them, but you can also treat functions as data. This is kind of an interesting thought. and do things such as assigning them to variables. That's exactly what we just did. So we will be dropping the ball. It says, like any other property, the untapped property of a shape has a type, but rather than an enter a string, the type of untapped is a function. Therefore, we can assign the function to it without the parentheses. This is kind of a weird thing. So you can assign the function to it as long as the function has no parameters and returns no results. Right? So we're not sending in data, we're not returning data. Therefore, when somebody hits the tap, it just calls the function by name. And since it's not returning or accepting values, it just executes. That's the whole point. So therefore, that's you know, the setup for a callback, basically. All right. We didn't write it with the parentheses at the end, right? And it says here in the book, it says that's because the parentheses after the function's identifier will call the function. In this case, you want to assign the function as a callback that will run later. So if we wanted to directly run the function on line 42, we'd include the parentheses, right? If we want to just queue it up so that we know that a tap calls the function, then there we go, right? So that just sets it up to run. It doesn't actually run it. All right. So now they're going to ask us to build and run the app. And when you tap the funnel, you should see your ball drop from it. So let's see if that's the case. So I'm going to kind of arrange my screen here a little bit so we can not miss the excitement. So here comes the run. There it is. Okay. All right. Well, my ball just dropped. I don't know about yours, right?
It dropped just
Yeah.
once. Oh, there we go.
So it started out where we originally told it to start out and it fell onto the barrier, but now it doesn't drop from the funnel until I click the funnel. Now, can I click anywhere? No, it's got to
Nope.
be on the funnel, right? And the reason for that is funnel on tap. So when the funnel is tapped, then we can trigger the function drop ball. Can I move the funnel? Like, can I move it here and then tap it?
Yeah.
It's still totally work. This is really, really goofy, but you know what? It works. All right. All right. So proof of concept. There's a callback, you guys. We got it to work. Woohoo. All right. What I'd like to do now is I would like to take another break.
Sure.
So I'm going to put us in pause mode here. Okay, we're back from our break and we're going to start working on part 4 now for the app build. And they're calling this section of the chapter tidying up. You know, it's kind of an interesting name. All right, and it says your shapes are a little boring. Okay, yeah, true. And the ball is way too big to fit the funnel, right? So that's kind of a thing. So now it's time to add a little artistry to the game is the part that we're working on. So we're going to learn a little bit about some of the terminology that goes with some of this GUI programming, not like we're trying to do a complete, you know, instruction on it, but just at least to give you a little bit of background. So we're going to start actually by coloring some of the shapes. You know, that's going to be one of the things that we do. And just for example, let's start out with the circle. So I'm going to come over here to the circle here. And actually, I was, you know, tempted to do it up here at the top where I'm declaring the stuff, but actually we're going to do this in the setup function, right? And so we're making the circle have a position, physics, and then putting it on the screen. But we can also add a fill color. So I can do circle dot fill color, right? And then we can give it the property of blue, for example. And notice the approach here, dot blue, right? So because this is one of the standard colors. And now that you guys have learned a little bit about types and enums and structures and stuff, you'll start to recognize the syntax that the color definitions are built into some sort of an object, and we can just pull them back with the dot blue, right? And if we knew the correct name of, like, aquamarine or whatever, however they declare it, we could put that in too, right? That's a possibility. All right, so there's the part that's making the circle blue. And okay, terminology wise, the fill color of a circle is what's on the inside of the circle. If you ever see a shape on a screen and it just has an outline, that's called a stroke. And these are terms from the art world. So the line on the outside of an object, or the border, if you will, is called a stroke. What's on the inside is called the fill. Right. And we saw that by just creating a circle natively without declaring any colors or anything like that. It's black, right? And that's just kind of the default. All right, let me see what else it says here. It says that you can customize the colors any way you want. Like, so just because I choose a certain color or the author is choosing a certain color doesn't mean you have to follow along with it. So you can make it as ugly or as beautiful or as special as you want. If you want to do all pink and red, whatever, it's on you, right? But you know what? We can also start to set colors for all the other objects too. So we did that for the circle. We could also add a color for the barrier. So I'm not really sure what a good color for the barrier would be, but come up with something, I'm sure. So we could say barrier fill color equals, and I'm not sure. I mean, you could just actually select from a list. So you notice I just typed the dot this time. And I can just kind of, I don't know, but whatever you do, try to be consistent with it. And I think that I'm going to go with, I don't know, purple for the barrier. There's my purple barrier. What else could use it? Well, the funnel could use a color. We could add that here. So we could say funnel dot fill color equals, and if I remember right from that video, they had it like gray. I might do something kind of like that. So let's go, I don't know, dark gray sounds good to me. And also, okay, the other thing that we noticed is that ball is clearly too big to fit through the funnel, right? And you could actually look at the funnel points, and basically the bottom ones, and figure out how far across it is on the bottom, and then make the ball fit within it. But you know what? I'm going to change what I have here for my circle definition, and the author is giving me some values that apparently he knows will work. But if you actually do a little bit of math, you can figure this out, right? Because you can look at the points that are at the top and the bottom, right, and figure out how wide the space is and how big of a ball would fit through the space. If you just, it's just a matter of math. But here's what the author recommends, is that we switch 150 to 40 and 40. So it's still a circle. So whatever the one size is, the other size is the same. All right, let's go ahead and run this, and let's see the color change, and we'll also see that the ball hopefully fits through the funnel, right? And if it doesn't, of course, you can tweak your numbers, but let's go ahead and run it. There it is, right? So there's my purple barrier, my blue ball. That's kind of a bright blue. Dark gray looks not too bad, but let's see, does it fit? It sure does. Oh, and that actually looks pretty good. The dropping does, right? So the ball is actually starting out inside the funnel or behind it or something. And then when we click, it looks like now it's actually falling out of it. So I think that's pretty cool. Yours is working, I assume?
Yep.
All right. All right. Now, the other thing that they're kind of pointing out is, let's take a look at our code overall and see if there are ways that we could clean it up. And so what they're kind of showing here, and I'm going to just pull the teacher guide over for just a second, is this is what the code that the author has is looking like. And let's see if ours is looking up the same way. Are we kind of in the same setup, oh, really, really, really close, right? Now, I'm not really necessarily sure that the order in which the author did things or the order that I did things, and you guys already caught me doing this because this is just my habit as a coder. For example, it doesn't make sense, for example, to put the circle on the screen and then give it physics and then give it a fill color. Wouldn't it make more sense? And this is what they're trying to point out here, to change the order. So let's put it on the screen, give it physics, give it a color, and then put it in the scene, right? So the grand point is here to basically rearrange your code so that those things happen in a logical order. Position makes sense to go first, coloring and physics next. It doesn't, I guess, kind of matter which order that goes in, but I'm going to say that, you know, I think that for me, I think I would probably do physics first and color second, but it could be the other way around. But I suggest that you follow a system that you're using all the way across. So like, for example, if I decide to put has physics first for the circle, it might make more sense to kind of do the same approach here, right? So we're going position, physics, color, mobile or not, and then add to the scene, right? We'll do the same thing down below, physics, fill color, add to the scene. And then we're setting up a callback here down at the bottom, right? You also notice that in the book, the author was adding comments, like I was kind of adding them. So add the circle, add the barrier, add the funnel. You know, if you wanted, you could also like, you know, label this and say, call back to drop the ball funnel. And if you find that helpful. Now, here's kind of the interesting thing here and what they're guiding us towards. And it says, and they're making a really good point. It says, as you've added more code to the setup function, it has become a little bit long. Right, so it's a little bit longer maybe than we might want it. How can you make it easier to read? And you have 3 distinct code segments, right? So each setting up a separate object. So in other words, this is setting up an object, this is setting up an object, and I'm trying to keep it orderly. And now I've like reordered everything to kind of put them in the same spots. So now we're going to learn about refactoring. And it says here, refactoring is the practice of reorganizing your code without changing what it does. So as you gain confidence as a programmer, you'll begin to get a sense for when your code should be refactored by splitting one function into multiple, creating a new function from existing code segments, abstracting data into new custom types or other techniques. And above all, your code should be readable, easy to debug, and well organized, right? And this, some of this comes with practice, right? So like when you first do this, you don't see it, right? But then as you get more practice writing code, you're like, you know what, this is really messy. I'm having a hard time figuring out what's what. And so just even me like ordering things in the same way helps me to see it and understand it better, you know, especially if I'm trying to fix something, then, you know, I have a consistent pattern that I'm following. So an interesting thing is to create a new function from existing code, you could manually declare an empty function, cut the code from setup and paste it into the new function, right? And that's how a lot of us would operate. But Xcode can automate the process for you. And what they're suggesting that we do is we try it now with the code that sets up the ball, right? So if we take the first 4 lines of code here in the main setup function, right? It doesn't matter if it's like exactly like mine, like if yours is different, it should be basically like mine. I can go to then the editor panel here, choose refactor and extract to method. This is really pretty slick, right? Other IDEs have similar tools, but I like the one that this one does. The other way to do this, by the way, is once the code's highlighted, you can right click and then do a refactor and extract to a method. And I'm going to tell you what, and this is, I always used to be very resistant to using tools like this because I felt that there was like some sort of like manly thing about like refactoring the code, manually and copy and pasting and moving stuff around like they suggested. Here's one thing that we ought to do first, and I'm just noticing this, and this is silly of me. Make sure you hit the stop button. You don't want to do this while the program's running, by the way. So go ahead and hit stop. Not a good idea to refactor while the code's running, right? All right, so whichever method you choose, whether you go to the menu or just create the code like that, do the refactor and extract to a method. And so notice what happened there, right? It does create a new block of code, and notice that it just indicates here extracted func, and it just kind of gave it this name. And you know what? It is set up with a couple of things that we haven't seen yet. The one thing is the file private keyword at the beginning, right? And basically what this is telling us is that if I was to try to access this code from an external program, it would not allow it to happen, right? It can only work from inside this code, right? Now, frankly, that's not really super necessary here. I'm not really too concerned about this, but generally speaking, we'll probably leave this alone, right? But watch what I'm going to do here, because this is already, I got two highlights on my screen right now. I want to give this a name that makes more sense, which, the author is suggesting we call it setup ball. I think I clicked off, there we go. I clicked off the screen, so I'm typing setup ball, which is what it does, right? It sets up the ball to operate. You notice how it's updating the name in both spots. Really slick tool, by the way, right? It says when you're all done typing the name, and just press return. And now in the main function, which is called setup, it just calls this external function, and then it'll execute all those tasks. This is really kind of considered a better way to do it generally in programming. Like if you have a series of steps that always happen, that you compartmentalize them and just call a function and execute them, because setup ball, well, that makes sense. That's what it's doing. It's setting up the ball, right? Then it's also now suggesting that we do the same thing for barrier. So I'm going to take this code, refactor, extract to a method. And what do you think we should call this? Maybe set up barrier, right? Press enter. Notice how setup changed down below. And let's do it for funnel too. And notice that the comments are getting thrown in here too, right? Helpful inside of a function to know what it does. And this one's set up funnel. Center or return, excuse me, to lock it in. And then we are also leaving this here. This is the callback. That's just probably going to stay right there. Now, after you complete these actions, right? I mean, you're still operating all the same code. You're just calling it now, as opposed to spelling it all out in detail. And like where you decide to place all this stuff, you can put it at the top, you can put it at the bottom. That's highly subjective, right? Either way, the function that's steering the whole program is basically this one, at least for right now. So this one executes. We set up the ball, it runs that code, set up the barrier, runs that code, set up the funnel, runs that code. And basically we're all good. Right. Now, one of the things that you may have noticed too, and they did this on purpose, by the way, is when we first created the ball, we didn't call it ball, right? We called it circle, right? Now, we could run this right now and test to see that it works, but I'm fairly confident it will. But you know what? Can we run it just to be sure?
Yeah.
Okay, still looks kind of the same. Still works just the same. I think we're good, right? But that's part of the incremental testing process. You shouldn't take it on faith. You should make sure, right? Because how long did it take? 10 seconds, right? So just go ahead and do it. All right. Now, the other thing they're pointing out again is that circle doesn't make sense. Maybe we should have called it ball to begin with. And so this is something that a lot of programmers are really uncomfortable doing, by the way, for whatever reason. And that is maybe everywhere in my code where I say circle, I should really be changing it to say ball to represent what it is, because the barrier is the barrier, the funnel's the funnel, right? Those are called the right thing, but the ball's called a circle, right? That doesn't really resonate very well. So there's a couple different ways that we can change all of it in the program, all right? So one way could be that you could go to the find menu and you could do find and replace, right? And then I also want you to notice the shortcut key for that's Command Option F. Right. So I don't know if you guys have ever used this feature in this program or real, frankly, any program. Right. So a lot of people, it always perplexes me that people don't know that this tool exists. So this works on web pages, by the way. This works in Microsoft Word and a lot of those types of programs. But what we're looking for here is the text that we're going to find and then what text we're going to replace it with, right? So here, as they kind of like coach you through this, it says Xcode can automate for this process as well, right? And let's go ahead and do this first by, if I was to look at all this and just go, okay, I'm just going to find every instance of circle and change it to ball, and I'm just going to do it manually one at a time, right? You see the process of that. Be a pain. This is pretty easy because we got like maybe like 5 references to it. The find and replace comes in really handy because I can just type find. What am I finding? I'm finding circle, right, in the project, replacing it with ball, right? Now, the weird thing here is, you know, and you want to be really careful because in project means all the files in the project. So what if there's a circle somewhere else that we didn't create that, you know what I mean? So you got to be really careful here. And you really probably want to make sure that you are in scope, basically. And select a circle identifier where it's declared. And I'm trying to read the instruction here because I'm trying to follow like what their instructions are, and I'm kind of fumbling with how they're saying it. And then choose edit all in scope from the editor menu. And I'm not sure what they mean by the editor menu. Yeah, and I think I'm in the basic right spot, but I think right, and here I am recording all this, right?
So
Hurting myself fumbling through the code.
I think I got it.
I'm in my scope, and I think basically that means here, right? I'm going to try this like standard approach here. Because this is basically our code. But I'm saying, you know, this is really kind of weird because it is grayed out. Not really sure why that is. Is yours also grayed out?
Yeah.
Mine is also grayed out.
Yeah, I'm not really sure how to necessarily fix that. Maybe if I unselect here, okay. So I'm going to read these instructions again, and I'm, you can use the find and replace. All right, so if I just do find and replace, it's still not all right, I'm gonna, I think, deactivate the tool. I'll switch to find. Let's go to replace. I think we would want to match case. I'm just wondering why it's not doing it. So I don't know if I have to like highlight all this.
Well, it's no longer grayed out for you.
Yeah, right. But I'm trying to figure out why it. So if I'm here, it works. I mean, that would make sense, but you can see like which things it's like limited to. Yeah, I'm just not getting it to. Reset here, basically. All right. The other thing that they're kind of saying is like where it's declared, which is here, we're supposed to be able to edit all in scope. And I don't see that as an option either. Are you guys seeing that?
No.
Yeah. Okay, so I wonder if this is a difference with the tool. And I feel like I have to like backtrack all my instructions here. I'm going to pause the video for a second because I feel this is pretty silly. All right, I'm not really sure how this was working, but apparently when I was clicking here, I had like filters on it and it wasn't finding anything, but I got rid of those filters and it kind of fixed things. I see your balloons there, Jonathan.
What?
I saw balloons come up on your screen. Did you see that, Jomar?
Oh,
I did see something pop up. Yeah.
I was like looking around, like what?
I think you just triggered a Zoom feature or something. All right.
Interesting.
So now this is looking like it's going to work. So I'm gonna go ahead and click. If I just click replace, right, it'll replace one at a time. If I click replace all, and I think all of these are correct, but I am also noticing here that there we go. So now it replaced all. Now I'm going to control Z that, right? And I don't know if I can. All right, so I did, but I want to like see if I can trigger that other feature, which is edit all in scope. And I'm just going to read the instructions again. Select the circle identifier where it's declared, which is here, right? Then choose edit all in scope from the editor menu. There we go. Now I'm seeing it. You guys seeing it?
Yeah.
I'm lost. I don't know how you got to
Yeah.
turn off the filter.
Well, you know what? I'll tell you what, let me just trigger this tool now that I'm feeling a little more comfortable with it, and then we'll take a look at your screen. All right. So I'm going to click this. And now in the spot where it's identified, this is kind of like setting up those methods automatically. I just type ball and you see how all of them change together. That's pretty slick. That's even better than find and replace. Then I'm going to press enter to lock it in. I'm going to pause the video and I'm going to take a look at your screen here. We're resuming. And so we did get that tool to work for everybody, but that you got to admit that's a really slick tool for being able to change all that stuff. And they kind of did that on purpose, right? And I think that second approach of edit all in scope is really slick. It's better than a find and replace. I mean, it's kind of like a find and replace on steroids, basically. All right, we're going to keep pressing along here so we can finish up this app. And we are now moving on to part 5, which is adding a target. And what they say here in the book is the next missing element from the game is the set of targets the players will try to hit with the ball. In this part, you're going to start by creating one target and you'll finish up with multiple arbitrarily placed targets that change colors when they're hit. So first thing we have to do is add a target shape. And the targets are those little diamonds that we saw in the original video. And that's going to, and we're using a diamond shape because it's going to be different than the other shapes that we're already using. Okay, so first we're going to add declarations for the polygon points and the target itself to the top of the file along with the rest of the shape declarations. And so like if you see like, ball, barrier, funnel, all that stuff, and then we go to our functions. So I'm going to put it here. And I'm going to say let target points here we are with the array again, and we're going to set up an array of points. And so we are going to set up the following. I'm going to copy and paste these in for, I guess, efficiency. But now that I'm thinking about it, remember last time it like brought a whole bunch of junk with it, so I guess I'm not going to do that. That's a byproduct of copying from that book. So there's some advantages. Like if I could strip that out of that book, that would probably be helpful. But we're going to do XYs for all these, so then we're going to do 10, 10 and 0, comma, point, Y. This one's going to be 0 and 10. Comma. Oh, so you can always copy paste, I guess, too. That's a technique. And then the third one should be 10 and 20. It's 10, 20. And then we'll paste another. And we want to get rid of the last comma there, though. And those should be 20 and 10. So 20 and 10. Those are the points. Then we're going to put in another declaration here of let the target equal, once again, the polygon shape. And what are we feeding in? The points, which are target points, which is an array. All right. Then we're going to add a function. And then we're going to set that up. So rather than add it to setup, we're going to create the function first, right? So if, and by the way, when I add this function, I'm not putting file private in front of it. And if you want to remove file private, you can totally do that, by the way. And that's what I'm going to do because the example that I'm looking at doesn't have that present. Right? Is that considered a good practice? Probably not. But you know what? Following an example. So, all right. So here we go. So we're going to set up target. Here's my curlies. And then do all the same stuff that we're normally doing. So let's do position. So we're going to say target dot position. And the position is going to be equal to a point that we declare. So we're just going to come up with an X and a Y. That X and Y will be 200 and 400. Then the target will have physics. So that's got to be set to true. The target is immobile. That will be true. All right. Well, here's another thing. The target, and we haven't tried this one yet, is impermeable. And we're going to say false. So in other words, it's recognized as being an object on the screen. It's not going to move around, and our other objects can travel like through it, basically. Right. So if it was true, then they would bounce off of it, and apparently that must be like the normal state. So we're trying to trigger the opposite state. We'll also give them a color to start with, so the fill color, and what the author is using is yellow. So I have no reason to not use that. And then finally, of course, we will add it to the scene. And what shape are we adding? We are adding the target. And of course, we're going to have to add that setup. So we'll say setup. Type it right though, setup. Target. So we're set up the ball, set up the barrier, set up the funnel, set up the target. All right, so now let's go ahead and run this when you guys finally get this code in here. And I have my screen set up now so you can kind of see the apps running and the code all at the same time. And so here's the run. There it is. And now you can see it. There's a little yellow thing there. Now, if I hit the funnel and drop the ball, right, you can see it goes right through it, seemingly. I think it's kind of interesting, you know, the order in which it goes on the screen, because the target was added last, the ball appears to go behind it, by the way. I don't know if you guys are catching that, right? And that can be either positive or negative. I'm not sure it's that big of a deal here, right? But this concept of when objects interact on the screen, that concept's called a collision on the screen, right? And you know, not that things are going to smash and explode or anything, but that's just what we call them. And so I'm moving on to the next little section here, which says responding to collisions. And it says for the game to work properly, you need to detect when the ball touches the target. Now I am going to go ahead and hit the stop button on the app. The API of the game engine handles collisions with callbacks similar to the one you already used to handle touches. Before you write the code, though, it's helpful to know a little bit more about how callback functions work. So it says function types. In the setup funnel function, find the line of code that sets the untapped callback for your option click on tapped, and then option click on tapped. Okay, so I'm just like reading it really weird. All right, so there it is. And now I'm going to option click this, and notice it changes to a question mark. And then it does this little thing here. It says a function that's called when the user taps a shape. And notice the get and set here, by the way, right? So like little tie-ins to other programming languages. All right, and you see this thing, right? And it's a little different from the other declarations that you're used to seeing, because there's a getter and a setter. So first of all, it talks about like why, you know, some of these things are specified in a certain way. Now, one thing that they're missing here, which the book points out, is this keyword public. And so just by the way, right, so whenever we're working with anything that's declared public in an application, that means it's accessible by any of the users of the application from any location, right? And so that, you know, Another way to set it is private. Now that's not being indicated here, but the book's talking about it, so I'm talking about it, right? Just, and that must be a version Xcode difference version or something, right? The keyword var, make sure that this is a variable because that could change, right? Absolutely. And then we have this weird terminology of parentheses, a pointer, and then parentheses, which tells it like we're, declaring types. It's kind of like a return type, like an int or a string or something, and then gets and set allows it to change values. Basically, simple as that. Now, this kind of thing is basically kind of weird because we don't exactly know what it's getting and setting, but we're setting it up to be generic so that it can just kind of absorb any kind of an action that we're throwing at it. That's really what it kind of means. So I'm just kind of reading through this to try to make sense of like their terminology here. It says you might be able to guess that the parentheses pointing to parentheses is kind of an arrow, and we know that this is basically some sort of a function type. But we also know that there's a return, so there's a kind of value that it returns. So the one function is returning a different function, but it has no parameters, and we're going to kind of basically leave it that way. So basically, the untapped property type is just a function type you can set as value to any function as long as the function has no parameters and doesn't return a value. So that's why they're empty in the situation. So what we need to do now is actually use a new type of callback. Rather than on tap, we're going to be looking for on collision. And so we're going to create this new piece of code that's going to say ball on collision. And the question is, where does that go, right? So I'm going to assume that that's going to be added here at the bottom. I am going to remove this comment here because it's not going to make sense anymore. So I'm going to say all dot on, collision. We're going to keep ramping this up, so don't like freak out to where we're at with it so far. All right, so if you now look, okay, so we haven't like actually utilized this yet, right? And if you read about on collision, so if I like do a option click on this, it's looking for a shape and then to trigger a function, right? So it says a function that's called when a physics-based shape collides with another shape or the boundary of the screen. So the screen is also a thing that we can collide with. Now it says that you can read function types. You'll recognize that on collision property requires a function that has one shape parameter and doesn't return a value. The shape that's passed to the callback function is the other shape involved in the collision. And recall that shape is a general way to refer to both oval and polygon shapes. The scene doesn't distinguish between these two types, so its methods and callbacks use the general shape type. That's why we just kind of have that word in there. You'll need a new function to handle the collisions between the ball and the targets. Create it now, right? So let's go do that. And we are getting an error here, but we're going to fix that. So that's kind of what the point is. So up here, we will now create a new func and we'll call it ball collided. And in the parentheses, we are going to add some stuff. I'm just creating the curlies first, but I'm going back to the parens now. And inside here, I'm going to say with other shape, and I'm going to go lowercase o here, other shape. What kind of shape are we looking for? The shape. We're pulling that right from this library. Inside here, we are going to say whatever that other shape is, and I'm trying to type this correctly. I just keep, oh, I see it. It's pulling the bad name that I typed here. It's not a shepera, it's a shape. So other shape, then whatever I'm feeding in, we're going to change that fill color to a different color once it's collided. Basically, we're going to change it to green to show that it's been hit, basically. Now we'll go back to that declaration here. And now we're going to add the equal sign. And we're going to call that new function ball collided with, just like that. Right. And it is pulling in that with colon. And, it's basically, a good idea, basically what they're pointing out is to use that with keyword, because the function definition is using that as the keyword. Right. And if you guys remember, and I already forget what these are called. This is kind of like the external name that we use for the internal variable. And the reason we're doing that is so it ball collided with other shape. If you guys are feeling, so we're just trying to make it more English readable is really kind of the goal. I could use a blank here too, but the fact that they're using with, we want to go with that basically. Right. So let's go ahead and run this. That's what they're suggesting now. All right. All right. And now if I go ahead and drop it, notice how it changes colors. Pretty slick, right? Yeah. Okay. So it turns green. But here's the other problem. The barrier also turned green, right? We didn't want that to happen. And so we're going to add the following code to set up target function. All right, so we're going to stop this. Let's stop this from running. And we're going to go to set up target, right? And add the following code. It says target.name equals target. So I'm not sure where to put that. My kind of feeling on this is I'm going to put it maybe right above the fill color. And maybe that's not where you want to put it, but you know what? That's where I'm putting it. Target dot name, and then in double quotes, target. Okay. So the point of that is basically that the name property that we're adding right now is just a way to identify shapes. So you can choose any string you want, and multiple shapes can have the same name. By default, a shape's name is the empty string, double quotes empty, right? But this identifies it as a target. And what we're going to do here is we're going to run some code to check to see if it has the name target, then change the color. If it doesn't have the name target, then don't. It's just that's really kind of what we're doing. So in the ball collided function, then we are going to basically add an if statement. So I'm going to add a line here at top, and I'm going to say if other shape does not equal, and actually I made a mistake here, other shape dot name does not equal target, then we're going to go right to a return statement. We're just going to do return. So what this does is it will pop us out of the function right there. So in other words, if it hits the barrier, pop out of here. We don't want the color change, right? So basically the function's done right at that spot. If the name does equal target, this won't trigger, the if statement won't trigger, right? And then the color will change to green. So Jonathan, there go your balloons again.
That one I caught. I'm not sure what is causing that.
Must have like some magic hotkey in Zoom or something.
My hand is off the keyboard. I've just been kind of just sitting here watching you in that one. Just
maybe some like Zoom hacker is taking over your screen.
Oh, I know.
All right. Now that we've made that little change to our code, let's run it again. And now we should see, right? Okay, now the ball dropped, right? And now it's not changing color. So you see how we kind of use the clever little property here to check a state and only change the color. So that seems to be working. I'm going to go ahead and stop it from running, right? So not too much more left to do here, but we are kind of quickly running out of time. So I'm trying to see if we can finish this whole app build here before we leave today. So now you know why I'm not doing those other parts of that that unit 3, because the app building takes a while, right? All right. So now we're in part 6, and this part in the chapter is called Refining the Game Mechanics, and it says stop the runaway ball. And so there's an issue with the ball that you'll see if you move the barrier out of the way, so the ball can drop from the funnel directly off the screen. Every time you tap the funnel, the ball exits with greater and greater speed. If you think about it for a second, you'll realize the ball doesn't stop moving after it exits the scene at the bottom, and it retains the momentum. All right, so I'm going to run this to kind of show you what they're saying. Right, so they're saying the ball dropped. Now there's a momentum that already built up. Now, if you guys know this about gravity, right? When you drop an object, gravity keeps accelerating that object at some exponential rate, so it keeps like building up speed. So if I move the barrier and now I hit the funnel, it just keeps getting faster and faster and faster, and that's not good, right? So we want to add this line to the drop ball function. And right now, all my functions are up at the top, and drop ball is at the bottom. I'm going to actually move this one. I'm going to do a cut on this and just move it up here. All right. And then we want to add a line here that says ball dot stop all motion. Right. So in other words, we're going to drop the ball in the funnel position, and then the ball will stop. All right. Now, we are still running the code, which is not a good thing, by the way. So I'm just going to run it again. All right. Then if I move this and I hit the funnel, now it seems to drop at a slower rate. Right. Very, very simple little addition. The other thing that we probably want to do is, if I click this and the ball drops, I can grab the ball and move it around, right? Maybe that's not what you want. And it says to make a game challenging, you won't allow the user to move. You'll allow the user to move the barriers, but not the ball, right? So if they could grab the ball and move it around, they can just move it around, hit all the targets, and they won, right? And that's not really very fun. So let's add another property to the, but this time we're going to add this not to drop ball, but to set up ball, right, up here. And so this is another property, and we're going to say ball dot is draggable, and that's going to be set to false. So they cannot grab the ball and move it around. All right. Now I'm going to hit the stop button again, hit the run button again. Once again, incrementally testing it. Now notice I cannot drag it. Drop it. Cannot drag it. I can drag the diamond. I can drag the barrier. Cannot drag the ball. All I can do with the ball now is drop it from the funnel. Better, right? Better for game, at least for the game, right? Now it says now do the same for the funnel and the target inside setup funnel and setup target. So we don't necessarily want either one of those to be draggable. Like, okay, so once again, we don't want the funnel to move. We don't want the little targets to move. All right, so set up funnel. So here I'm going to say funnel dot is draggable equals false. We don't want that to be moved around. And then for targets, we'll also set that property. Target dot is draggable equals false. Stop the app from running again. It's curious that you can actually keep it running and change the code, whatever. Not a good idea generally, but now I can drop the ball, right? I can't drag the ball. I can still drag the target or the barrier, right? And I cannot drag that. and I cannot drag that, just to verify that it's working, right? Little changes, make sure it's working, then you can come back and test it again. So that's the dragging is now turned off. Now we're going to lock the barrier and right. Okay. The three other things that are on the screen, the ball, the target, and the funnel should never move, but the barrier, maybe, right? It says, but since the barrier needs to be draggable between drops of the ball, the code to handle this rule is a bit more complicated. So you have a function that drops the ball. So it's reasonable to lock the barrier there, right? So that's kind of a thought, right? Right now, the ball falls forever, even when it leaves the bottom of the screen. The scene doesn't have any physical boundaries, and neither does the physics simulation. The right time to reset the process and re-enable barrier interactions is after the ball has disappeared. So the first thing we want to do here is to create a function to handle basically, and what they're saying is to act as the callback for when the ball exits the scene. So we're going to create a new function here, do it right above setup, and I'm going to call it func ball exited.
Bless you.
Bless you.
Thank you. And then we got our parens and our curlies. And it says next, add this code to basically let the scene know it should keep track of the ball's location and set the callback on the ball. So first we're going to do scene dot track shape. Kind of interesting. So there's a tool built in that tracks where the thing is on the screen and keeps track of it. Very nice, right? Then we're going to take the ball and we're going to say, and this is kind of interesting syntax here, on exited scene. So this is a built-in property here. We're going to execute our callback function ball exited scene. Once again, no parents, it's here because it's just going to do this thing and it's going to trigger on that callback. All right. All right. So now we're going to add this. It says now you can lock and unlock the barrier and add the following code to the drop ball function. Right. And so we have the ball position, we have stop all motion, and then I'm going to add here, and I'm just thinking about this, like where okay, so the barrier is draggable, will be false. And then to the ball exited scene function. So so I want you to think about the logic here. After the ball has left the scene, then you can move the barriers, but not while it's dropping, right? So you're not going to like try to catch it, basically, right? Because that would make it too easy. So barrier is draggable, then becomes true. All right. It says now build and run your app, and initially the barrier should still be movable. After the ball comes to a rest on it, move it out of the way so that it falls off the screen. And when it's dropped from the funnel, tap and watch the funnel drop out of sight. And when you tap the funnel again, the ball will drop. But if you move the barrier out of the way, the ball is in place, it should remain in place. The ball is out of sight. You should be able to move the barrier again. All right. Did you catch all that? Right.
Yeah.
I think it's kind of intuitive, right? You know, and I'm just trying to read what they have there in the book. So there it is. I'm going to move it out of the way so it drops. So it is movable. Now I'm gonna drop it, and notice I can't move it, right? Okay, so I don't know if you guys are catching the problem with this, right? And the book's pointing it out. To see it, move the barrier back in the ball's path and drop the ball. When the ball comes to rest in the barrier, it won't be able to do anything but drop the ball again. That would make poor gameplay. I'm not sure I've got this exactly how they want it. right? So I guess I'm struggling a little bit with understanding what they mean. Right, so here I can move this. Now, if it drops off the screen, I can't move the barrier. So is there maybe an error with how I got my code? Is your code operating the same way, you guys?
Yeah.
Yeah.
You can't move it, right?
Um. Let's see. I'm trying to think here. Um,
It says once the ball is out of sight, you should be able to move the barrier again. And I
But the
think
ball is not out of sight. It's
yeah, and
still
I think I know what I'm missing here. What did you just say, Jomar?
the ball isn't out of sight. It's still on the screen. So maybe that's the issue.
When I say once it comes off the screen, you should be able to move the barrier again, but I'm not getting that effect.
is it not truly off the scene, off the screen?
That's kind of what I'm thinking. I'm just going back and looking at the instructions again. So we have a function called ball exited scene. We put scene, and I'm just gonna pull a book over just so you can see this is what I'm following right now. Right. So we created that function, right? We can see it right there. We added scene, track shape ball, got it. Ball on exited scene, we trigger the func as a callback. On the next page, they say, now you can lock and unlock the barrier, add the following code to drop ball. So here's drop ball, barrier is draggable false, right?
Mm-hmm.
And I'm just really wondering, did I put this maybe in the wrong spot? Okay, so here's my experiment. Let's stop the program from running. I'm going to cut this and put it here. I'm going to try it again. Maybe that's the secret sauce. Let's see. There it is. So I'm going to move. There it drops. Nope, still doesn't do it. Yeah, I'm not sure what the answer is to that. So I'm just going to control Z that. My thinking is I probably had it right to begin with, but there's some flaw in the logic here that's preventing it.
Do we have to add anything to the setup function?
You know, you're thinking like me, right?
Mm-hmm.
Yeah, so this is kind of interesting because I'm recording it all, but I think that's okay because okay, so we set up is draggable false on both of those, right? Is draggable false for target. Is draggable false for funnel. All right, let's see if I missed like an instruction here, right? All right, so we set up that function, which we did. Ball exited scene. And it says next, add the following code to set up ball. Did we put that in the wrong spot? scene, track shape ball. Yeah, we put that in the wrong spot. So these two lines should not have been here. So eventually we figured it out. Those should be on setup ball. This is where you got to read those instructions super carefully. And so I'm going to paste them here. And you know what? It seems to me like they shouldn't be in the middle. Should probably be at the bottom. It's because we want to put the ball in the scene first. Then we'll track its shape. Then when it leaves the scene, we'll trigger that function. All right. So I think we got the logic here now, correct?
Yeah,
Yeah. I don't know if you guys are trying it already.
I'm running the build now. I'm waiting for it to load.
All right. So I'm gonna do the same thing here on my end. Let's do a run. There it comes.
It works.
Yay. All right. And now it fell off the screen, so I can still move it. Right. And then I could drop it. And then I can still move it. Okay. So I think we're good. All right. So the next task then, I'm going to stop this run, is to set up a reset for the game. And let's add that function. So once again, I'm putting this right above setup. So just keep adding them here, but keeping everything above the setup function. This I'm going to call func reset game. Parentheses, the curly brackets. And then the code inside here is basically we're going to reset the ball position is what we're going to do. So we're going to say ball dot position. And we're going to put it basically up in the funnel, right? So we're going to say point. We're choosing an XY and we're going to put it at 0 and minus 80. Now keep in mind, the top of the screen is 0 for Y. So minus 80 pushes it above the screen. So it's out of view, right? So it can drop right through. Then we will then set it as the ball's callback and set up ball. So now we're going back to set up ball. And then here we'll say ball dot, excuse me, on tapped. We'll say reset the game. So if we tap the ball, it resets the game. And it says it'd also be better if the game started without the ball on the screen. So add a call to reset game at the end of your setup function. Let's go to setup. And at the very end, we will say reset. Okay. Now, when you build and run your app, you shouldn't ever get stuck in an unmovable and unwinnable state. All right. Yeah, that's kind of a good thing, right? All right, so the ball's not on the screen now. Now I can drop it. Right, I can't move that. But now I can tap the ball so I can move the barrier, right? So if I catch the ball, I can then tap the ball to reset. Okay, so excellent. All right, so now we're in a good situation. I'll hit the stop button again. So now we're on part 7. It's challenging the user. And what we're going to do first is we're going to allow, I mean, because if we have a flat barrier, it's going to bounce like straight up and down, and it's not very exciting. We want to put some angles on this. So we're going to put in a tilt to the barrier. And we're going to now modify the setup barrier thing. And we're going to put in basically another property here. And we're going to say barrier dot angle equals, in this case we're going to start with 0.1, right? And now, you know, I'm not sure exactly what their parameters are here for this, but you know, so this is no longer going to be flat, it's going to be at a slight angle. The other thing that we are going to do is we're going to make the ball a little more bouncy, right? So that when it hits something, it has a little more lively. And so we're going to actually go up to setup ball. And somewhere before we add it to the scene, we're going to say ball dot bounciness. And this is a property, by the way. We're going to set this to 0.6. So it increases the bounciness. I don't know what normal is, but probably 0.5 is normal, you know, is my guess, right? The next thing that it says here, since the game is physics-based, it would take a lot of trial and error to work to build a good challenge. Instead, you'll build one that's already solved and use it to reverse engineer the code. So adjust the bounciness of the ball and the position, size, angle of the barrier until you have a bouncing mechanic you like, right? The reverse engineer challenge, you'll drag the target around so that it lies in the path of the ball. To figure out the correct coordinates, you can use a helper function or print a log of the shape's position to the console. All right, so they're suggesting this function here. And I'm going to add this in. So here's func. And it says print position becomes the Swifty stuff of shape, you know, shape, whatever shape we're working with. Here's the curlies. And then inside here, we're just going to do a print. This is only going to go to the console now, right? So keep in mind, the iOS won't see this, but the coders will see it in the console of the program running, or the log files, basically. And what are we going to, oh, we're not going to put quotes here. Sorry. We're just going to say whatever shape is fed in and its current position, and that will just be printed as coordinates. All right, so now it says use the on shape move callback of the scene to print a new position every time a shape is moved. Add the following line to the setup function. All right, so we're just going to put this, I'm assuming, down here at the bottom. We're going to say scene dot on shape moved equals a call to print position up. Okay, then what they're asking us to do is to make sure that we can manually move our targets around. And in order for that to happen, we have to come up here to the setup target area, and where it says is draggable, we're going to comment that out temporarily. So just put a couple slashes in front of it. And that way we can move the target around. So we can test the code that we just thing. And now it says they want us to run it. Now notice our angle, right? There's our funny angle. It says, now watch as your ball drops and bounces, pick a point along its path and drag your target there, right? So we can move this. So I'm gonna drop it once, see it bounce. Right now it's super bouncy. And are you guys noticing as I'm moving the target, how the XY positions here are changing? Pretty slick,
Yeah.
right? Yeah, it's pretty slick. And now we're going to move this back to a spot where we know it's going to hit, right? All right. And now the kind of the interesting part about this is, right, like, so here's what they're really trying to have us accomplish. As we drop this, the ball's going to bounce. And now the color's not changing the green because it's already like run, right? How do we reset the game? Tap the ball. This didn't change the yellow though, right? Here's the point. When it bounces and we know it's going to hit, we can note that location, and it's because we ran that function, we know those locations, so we can program stuff to be in those spots. That's really the point here, right? To capture that information. When you're satisfied with position, note the values printed to the console, then update setup target to set the target's position. You don't have to worry at all about the digits past the decimal. Finally, comment back in the line to disable dragging. All right, so this isn't like maybe as complicated as the one that we saw, but we are basically fulfilling at least this part of it. So what they want us to do now is I'm going to notate this position 107, 305. That's X and Y. So in the setup target, I'm going to switch those. I'm going to say 107 and 305. I'm going to stop the app from running. I am going to switch this back to not being commented, and now I'm going to run it again. Now you see the target. When I hit the funnel, it should drop, should hit the target. Very good, right? Maybe not super magical, but hey, it is what it is, right? And of course, if I move my barrier, it's going to change the physics, but it should probably still hits it. Okay. All right. So the next part of this app build is to really create the more complicated pieces that go with it. And here's what I'm going to do, you guys. I'm going to pause this recording for just a second. All right, because this is a actually fairly complicated little app build, and we have a couple more parts left to do. And the parts that we have left have more code than all the code that we've created so far, right? And if you remember that demo video from the beginning, we're going to add a bunch more targets. We're going to add more barriers. And then we're going to have to find a way to keep score, all of those things, so we're building the pieces incrementally here. Unfortunately, we don't have enough time to finish that all today. We have a very few minutes left in our session here. So we're going to stop this video here. So we'll call this Bouncy Ball App Build Part 1. And then next week when we come back together, we'll finish off the app build. That will probably take a good portion of the session, by the way. And the other thing to put on your radar too is we are going into Thanksgiving, so I'll try to factor that into the mix in terms of how much time we spend in class working on this. But this is a lot of fun. I think, I get more of a thrill out of building goofy little apps like this than thinking about conceptual aspects of code all day long. But knowing conceptual aspects makes this a lot more rewarding when you actually get to it. All right, so this video will end here, folks, and then we will resume this app build next time.